Okay, onward and upward, everybody. Moving ahead to section 5.4. This section is called something like trig functions of real numbers. Really, what we're doing now, if I was going to relabel it, I would call it sort of building and using the unit circle. What the heck is the unit circle? So I plotted this out a little bit beforehand to try to get a semi-decent circle drawing. Excuse me. So the unit circle is on the xy plane. The center is at the origin, right, which is our point 0, 0. And the thing that makes it the unit circle, right, is that the radius is equal to 1. So the radius of a circle, right, is the distance from the center out to the edge. So the idea is that distance from the center point out to the edge from 0, 0 out to the edge is always going to be 1. Let me start to kind of sneak our picture in here, right? So we're talking about all the distances here from the center out to the edge. So that length, right, at sort of any of these different angles, is going to be 1. So what is that length? Well, if we drew an angle in here, so say, for example, I drew, right, a 45-degree angle. So if I did that, right, what I'm essentially getting at that point is the value, xy, right? I'm getting a point on the terminal side. The angle itself, of course, is sort of rotating in here. I get a point on the terminal side that's on the unit circle. And so the radius value is going to be 1. So on the unit circle, right, for a point xy, my radius is 1. And so what that does is it simplifies my life with respect to finding trig values, in particular sine and cosine. So the sine of theta should be the y value at the coordinate divided by the radius. If the radius is 1, right, y over 1 is just going to be the y value. It's just going to be this y coordinate. Cosine is supposed to be x over the radius. If the radius is 1, x over 1 is x, right? So the cosine value is x, and the sine value is y. So on the unit circle, right, with this very particular setup, we're going to get points, x, y, on the edge of the circle, and the point values are going to give us directly the cosine value at the angle and the sine value at the angle. Cosine is going to be the x coordinate, and the sine value is going to be the y coordinate. Let's do a couple that we would sort of know already. We've kind of done this already for things like the quadrant angles. 0 degrees, right, is 0 radians. So the point here, if this is 1, this is going to be my x value, right, is 1. My y value is 0. So the cosine at 0 is 1. The sine at 0 is 0. If I go up to 90, right, so now my x value is 0. My y value is 1. So now cosine at 90 is going to be 0, and the sine at 90 is going to be 1. And then we can sort of go and fill in the rest of these, right? This is going to be negative 1, 0 at 180. This is going to be 0 and negative 1 at 270, right, or 3 pi over 2. Once we hit 360, we're back to where we started. We're doing things over again. So those we kind of had already to a certain extent, right? We're sort of moving around the circle. We get zeros and ones, we get positives and negatives. The things that are a little bit more interesting for us and really going to be a nice sort of resource for us is, instead of necessarily having to build our special triangles each time and sort of set it up and do the division to get values for 30s and 60s and 45s, we can sort of, in theory, do some of that work beforehand and plot out all the different coordinates based on it. So at 45 degrees, what we're going to get are the x and the y values are the same, because they'll be the legs here. If we drew the 45, 45, 90 triangle, right, it was like 1 and 1 and root 2. But this is a 45-degree triangle where the radius is 1. And so what happens to us here is the x and y coordinates are still the same, but they're going to look like root 2 over 2. So at 45 degrees in radians, right, would be pi over 4. We're going to get pi over 2 and root 2 over 2 and root 2 over 2. So what's interesting here is not so much that we're necessarily able to do that, but we can really sort of visualize and see all the connections across the different quadrants. So for example, say I took this and I went just like straight down and across. You'll notice in my circle, even though I took all this time to draw it, I kind of misplaced my x-axis a little bit. So my angles are not perfect. This is 180 supposed to be plus 45, so that would be 225 degrees. This would also be 5 pi over 4. And so the coordinate that we get, right, this is my third quadrant, quadrant 3. So what's going to happen here as far as my x and y values go is I'm going to get the same digits, root 2 over 2, but now in the third quadrant, both the x and the y values are negative. So you get negative root 2 over 2 and negative root 2 over 2. If I do versions of 45, right, in quadrant 4, or up here in quadrant 2, this would be, I need to shift this just a little bit to draw on it, right? So this would be 135 degrees, 3 pi over 4. So here, right in quadrant 2, my x is negative, but the y is positive, so still working with root 2 over 2. So negative root 2 over 2, positive root 2 over 2. Down here in quadrant 4, so this is going to be 315 degrees, which is 7 pi over 4. So this is what? Positive x, but then the y value is negative. So you get this really nice kind of correspondence, right? 45, 45, 45, 45, 45 degrees, the reference angle for all these things, and so you get the same coordinates. You just have slightly different signage, right? So positive or negative based on the quadrant. If we wanted to do a similar thing for 30 degrees and 60 degrees, we can. Let's do that. So our 30 degrees maybe looks like this. That would be pi over 6. Our values here, if we get them from our similar, our special triangles, it's going to be root 3 over 2 for the cosine, so the x value is root 3 over 2, and then it's going to be 1 over 2 for the sine value. You can kind of imagine drawing in, if this is your 30-degree angle, your 60's up here, you can kind of label it and sort of get to those values accordingly. And then the same kind of thing, if we take this, right, we kind of sketch it across. If we've got 30 degrees in quadrant 2, and we sort of carry that across, right, to 30 degrees in quadrant 4. So all these guys sync up, and so then we can label, they're all going to be this sort of root 3 over 2 and a 1/2, but positive or negative is going to sort of change as we go around the circle. I'll sort of label them a little bit out of order. Double negatives down here in quadrant 3. Negative x and a positive y up here in quadrant 2, and then this is a positive x and a negative y. What are the angles here? This is going to be 150 degrees. That's going to be 5 pi over 6. This would be 210. That would be 7 pi over 6. Every 30 degrees is 1 pi over 6, right? So this is sort of 5 over 6. 6 over 6 is 1. 7 over 6 is here, right? This 2 pi would be like 12 over 6. So this would be 11 pi over 6, or 330. So we get this nice correspondence. So all these red angles, all these red positions are my 30-degree angles. The last version is going to be the 60 degrees. We put those in, so that's going to be kind of 15 degrees past the 45. I'm not drawing this perfectly right. I'm not getting a protractor out necessarily to make this work. In theory, this should be sort of 30, 30, 30. That looks semi-decent in that first quadrant. Try as I might to make this look as good as possible, of course. I'm still only human, so I can only draw it so well. This is going to be, what did we just say, 60 degrees. So that's 1 pi over 3. What happens here, right, so 30 degrees versus 60, right, the triangle sort of flips positions, the 30, 60, 90. So the sides, the opposite and the adjacents kind of flip over, so we get the same kind of coordinates here, but they've flipped positions for the x and the y. Take this guy down, get a version here. we do a version quadrant 2, you can trace it down, get a version here in quadrant 4. Again, this is not perfect, but I don't know, it's okay. This is going to be 2 pi over 3. So each of the greens, right, is sort of 60 degrees is 1 pi over 3. So that's 1 pi over 3, that's 2 over 3, that's 3 over 3. It's not a bad exercise to almost like divide these up and sort of draw them like one type at a time. The book actually kind of does that when they're sort of originally drawing them out. Double negatives down here, negative 1/2, negative root 3 over 2. What's that? 240. So that's going to be 4 pi over 3. And then this guy's going to be 300. Would be 5 pi over 3. So last but not least, so positive 1/2 positive x's and then negative root 3 over 2. Whew. So building up this triangle, right, it takes a minute. But, you know, I think it's worth it. I will show you just down in the corner. Well, no, let's pause for there. Anyway, that's our unit circle. Those are our main points. What we'll do next is actually use these to find our trig values. So I sort of said, right, the main idea here is that the sine value is going to equal the y coordinate, the cosine is going to equal the x. We can obviously sort of flip those values around to get things like cosecant and secant. And then if we wanted to get a tangent or a cotangent, right, tangent and cotangent still are just based on the x's and the y's. Tangent is just the y over the x, and cotangent is the reciprocal. So having the radius one, in some sense, doesn't really affect the tangent values. I mean, I guess it does only in as much as we're sort of fixed on these particular coordinates, these particular sort of values. I mean, these would be the results if we simplified the trig values down. So this is our unit circle. We'll have this as a reference, but it's good to take some time and sort of build it up, at least kind of once or twice. I think it's good practice just to get the visual of what it looks like, and then to sort of help yourself learn the patterns of where these numbers go. You don't have to memorize it, but the more you work with it, the more familiar you are, the better off you'll be.